My name is Ruiyun Huang, and my project is face recognition using PCA algorithm. With the development of information technology, biometric identification has attracted more attention, especially the human face recognition. There are many kinds of biometric identifications, like the fingerprint, the iris, and the human face identification. Based on the human face images, there is no need to contact with the target, which makes it more convenient than other methods. Due to its convenience and accuracy, the face recognition has been applied in the identification of criminals and the bank account and the human-computer interaction systems. My project is to implement the face recognition based on PCA algorithm. The MATLAB will be used to realize the PCA algorithm and the recognition process. The training set and the testing set will be use the Yale and ORL face database. Here is the introduction to PCA. PCA can use low-dimensional vectors to reconstruct the original high-dimensional images by removing the correlations among the different inputs. Here we use PCA to extract the features of face images and construct the eigenface space. For example, a face image with size of n by n can be expressed as this. The xi is the row vector, and I can compute the covariance matrix Cx. The covariance matrix contains all correlations in the image, and the diagonal elements is the variance. The larger diagonal element means its corresponding variable is more important, and the non-diagonal elements is the covariance. They are usually the noise. So we need to minimize the non-diagonal elements and maximize the diagonal elements. That means we need to diagonalize the covariance matrix, and the CW is the diagonalized matrix. Also, the row vectors of P are the principal components of data X. The principal components are the eigenfaces we need, and the W is the projection of X on the eigenface space. Here is the face recognition process using MATLAB. I use the images from database to create the training and the testing dataset. Then I implement PCA algorithm and get the eigenface. The face recognition compares the Euclidean distance of the training images and the testing image. And the output is the matching image of the testing face. I choose Yale and ORL database as the training and testing set of the face recognition. The Yale face database has 165 images, and the ORL face database has 400 images. Before calculating the eigenface, we need to normalize the face images. The two-dimensional face image matrix will be transformed to one-dimensional vector T, and the mean vector M will be calculated. Subtract T by M, we can get the normalized image matrix A. Here is the mean face image of one person in the training set. This is the comparison of original face images and the normalized images. The covariance matrix C can be get from this formula. A is the normalized image matrix. We can get the eigenvalues of C by calculation, and the eigenvalues are the eigenfaces we need. The eigenfaces are used to compare the distance between the test image and the training samples. And this is the comparison of the original images and the eigenface images. The Euclidean distance between the projection of testing face images and the training face images will be used to find the matching image. The training image with the minimal distance from the testing image is the matching image we need. Because PCA transfer image matrix to one-dimensional vector, the computation will be complicated and slow, so I use two-dimensional PCA to optimize it. It is based on the two-dimensional image matrices, and it has smaller computational complexity, and it improves the feature extracting speed. Here is the introduction to two-dimensional PCA. A is the original image matrix. We also need to calculate the mean image of A. Then the covariance matrix G can be get from this formula. Just like the PCA, I also need to calculate the eigenvalue of G, which is lambda. Then I need to find R lambda that contains 19% information of original data, and this R lambda will be chosen as the principal components. To test the performance of two-dimensional PCA, I choose different numbers of training images per person in the ORL database. And the output is the comparison of a two-dimensional PCA and PCA. The number of training images are 34 and 7, and here is the accuracy of the two-dimensional PCA and the PCA. From the output, we can say the accuracy of two-dimensional PCA is higher. My project realized the face recognition based on the PCA algorithm, and from the experiment result, I find the recognition rate is high. Even the testing images has different facial expressions, and I optimized the PCA algorithm based on two-dimensional PCA. It simplified and speed up the face feature extraction, and the result also shows the two-dimensional PCA has higher recognition rate than PCA. Thank you. And here is the MATLAB program of PCA. I need to select the training set path. Then is the test set path. Then I need to enter the test image name. There are 45 images in the testing set, so I choose 6. Okay, here is the output. We can see the matching image. This is the optimization program using two-dimensional PCA, and I choose the number of chaining images is 3. And here is the output. From the output we can see the recognition of two-dimensional PCA is higher than the original PCA algorithm. I tried 5. When the number of training images are 5, also the two-dimensional PCA has higher accuracy.